So at this point, you guys should feel fairly comfortable graphing things in slope-intercept form. That's y equals mx plus b. This video is going to talk about other situations going along with graphing lines that maybe aren't as immediately obvious to kids. Places where you will see kids make mistakes. And the first of which is going to be graphing horizontal and vertical lines. So let's say they asked us to graph x equals 2. The line x equals 2. Just x equals 2, no y, no mx plus b. It's kind of weird. It's like, well, how do you even do that? I want you guys to think about it like this, because it'll be really helpful in making sure you don't make mistakes down the road. X equals 2. That graph is saying I want everywhere where x is equal to 2. All the spots where x equals 2 are on my graph. Well, if we think about x comma y, x equals 2 is right here. This would be 2 comma 0. This would be 2 comma 1. 2 comma 2, 2 comma 3, 2 comma 4, 2 comma negative 1, 2 comma, you can do negative 1.5. All the spots where x equals 2 are on this green line right here. So the line x equals 2 actually looks like that. So x equals 2 is a vertical line at 2. I'm going to come back and make a comment on this in a little bit, but I want to do my second example first. Y equals negative 3 is saying I want everywhere where y is equal to negative 3. Well, if you think about your coordinates for a second, this would be 0, comma, negative 3. This, I guess I'll go back to my green, sorry. So that'd be 0, comma, negative 3. If I were to go right here, that'd be 1 comma negative 3, 2 comma negative 3, 3 comma negative 3, 4 comma negative 3, negative 1. All the spots where y equals negative 3 are along this line right there in green. So this is going to be a horizontal line at negative 3. It's everywhere where the y coordinate is equal to negative 3. Now, I guarantee it's going to happen. It always does. Kids will get these two mixed up. When you think about x, you're typically thinking x-axis. You think going left, right. But x equals is a vertical line. You look at that right there. It's everywhere where the x coordinate is 2. Y equals negative 3, people think, why? Oh, the y-axis, it's going to be going up and down. Y equals negative 3 is a horizontal line. You have to be able to keep these two things straight. They're kind of the reverse of what you'd think they would be. But I explained why it works and try to make sense of that. That's important. Don't forget, it kind of does the opposite of what you would think on this. The second topic of this video, in terms of extra stuff going along with slope and such, is the idea of parallel and perpendicular lines. And hopefully you recall from geometry that parallel lines are lines that never intersect. So lines, if you wanted to get an official definition like in geometry, you talk about them being in the same plane. So I guess I'll put that in parentheses, but it's not, just so I'm not like incorrect when I write it on here. But it's basically lines that don't intersect. So parallel lines would be things like these right here. Those lines are going to go on forever without ever crossing. They kind of stay the same distance away from each other as they go on. The big thing with parallel lines is that they have the same slope. And I will show an example of that. So parallel lines have the exact same slope. If I had the equation of the line y equals 2x plus 1, the slope of this line right here is 2. So if I were to have the equation y equals 2x minus 3, they have different y-intercepts, which is fine, but the slope is the same. So those two lines will be parallel. And I'll actually graph that so you guys can see that firsthand. So y equals 2x plus 1. There's plus 1. I would go up 2 over 1. That line looks like this. And y equals 2x minus 3. There's negative 3. Go up 2 over 1. Looks like this. And you can see that those lines right there are parallel. Perpendicular lines are lines that form a right angle when they cross. So lines that intersect in a right angle. And the deal with perpendicular lines in terms of their equations is that they have opposites, reciprocal slopes. So opposite reciprocal slopes. And let me draw an example. I forgot to do that on this one. So you can see what perpendicular lines look like. They're going to make a right angle when they cross. So it would be something like that. So let me give you an example of what that would entail. So let's say I had a line. Maybe I took the equation y equals, let's go with negative 3x. That was my first equation. Negative 3x means that my slope is a negative 3. So there's two parts to this. Opposite, reciprocal. Opposite means you're going to change the sign. If it's positive, you make it negative and vice versa. My slope was negative. Now it's going to be positive. And reciprocal, remember, think about back to fractions, means you flip your fraction over. So reciprocal here, if my slope was negative 3 over 1, it's going to be 1 over 3 right now. So my perpendicular slope has to be a 1/3. So I'm going to do y equals 1/3 x. And this number can be whatever you want. It doesn't really matter on these if it's the same or not. Just for a nice simple example, I'll keep it like that. So just 1/3 x, but I could put a number there and it would still be perpendicular. So let me graph these real fast to show you guys, verify that they do look perpendicular. Negative 3x starts at 0 and it goes down 1, 2, 3 over 1. So there's my first graph right here. Looks like that. And 1/3 x still starts at 0 because I have a plus 0 there. I'll go up 1 over 3. It would look like that. And when I draw these, it's not exactly perfect, but you can see it's pretty darn close, even with my sloppy picture here, to a right angle.